In this section we are going to look at the substitution technique for indefinite integrals. Substitution is similar to chain rule, and in fact you can think of it as the process that undoes chain rule. For the first example, let's find the antiderivative of cosine of x squared times 2x dx. You see we have a composite function, where there's an x squared inside the cosine of something. And we also have the derivative of the inner function x squared in the form of 2x. That's exactly the situation where we use substitution. In this case we are going to make the substitution w equals x squared. Now we also need to replace dx. Since the variable of integration is in terms of w, our integral should have a dw at the end. To substitute for dx, we take the derivative of w. This gives dw dx is equal to 2x. Now we use algebra to solve for dx. When we do that, we end up with dx is equal to dw over 2x. Now we plug in and simplify. We replace x squared with w and dx with 2x over dw. After we do this, we see that a 2x can be cancelled, leaving us with just the indefinite integral of cosine of w times dw. This is an integral we actually know how to do. The antiderivative of cosine of w is just sine of w and c. We want our answer in terms of x since that was the original variable. We make the substitution w equals x squared to get our final answer sine of x squared plus c. For our second example we will look at the definite integral of quantity x squared plus 7 raised to the 100th power times 2xt. You see we have a composite function, where there's an x squared plus 7 inside the argument of cosine. We also see that the derivative of x squared plus 7 is showing up as 2 times x. So we can look at substitution here. We make the substitution w equals x squared plus 7. Again we need to solve for dx and replace it with an expression involving dw. In this case dw over dx is equal to 2x. Solving algebraically we have dx equals dw over 2x. We plug w equals x squared and dx equals dw over 2x into the integral to get the new integral w to the 100 dw. This is one that we know how to do using basic power rule on w to the 100. This definite integral will be 1 over 100 plus 1 times w to the 100 plus 1. However, we don't want our final answer to have any w terms. This started out as a function of x, and we want it to end up that way. We know that w is equal to x squared plus 7, so we plug that back in for w. As a final answer, we have that this indefinite integral is equal to 1 over 101 times quantity x squared plus 7 raised to the 101.